Wondering what lies on Jupiter? What is contained in those rings around Jupiter? If yes, then you have just landed on the right video. Hello everyone and welcome back to my channel. Today I'm going to talk to you all through what James Webb has discovered on Jupiter. So make sure to sit back and stick with us till the end of the video so that you don't miss anything. Now without any further ado, let's dive straight into the video. Images of the largest planet in the solar system were captured by James Webb Space Telescope, the JWST. Jupiter has a lot going on, including enormous storms, strong winds, auroras, and extremely high temperatures and pressure levels. Webb's views of Jupiter will provide researchers with considerably more information about Jupiter's interior. The $10 billion JWST is a global mission coordinated by the European Space Agency and the Canadian Space Agency, with support from the US Space Agency NASA. The JWST was sent into orbit in December 2021 and is now almost 1 million miles, that's 1.6 million kilometers from Earth. When the first James Webb Telescope images were shown to the public this year, the whole globe gasped in awe and shock. People from all across the world were mesmerized by every tiny detail in these images, which included merging galaxies that were millions of light years away and planets outside of the Milky Way. The inaugural data released from the James Webb Space Telescope showed that in less than a year, this remarkable telescope has given us a wealth of knowledge about our cosmos and drastically changed the way we perceive it. The Sun's distance, according to experts from the University of Colorado in Boulder, Jupiter's atmosphere, which is mostly made of hydrogen and helium, is comparable to that of the Sun. At the planet's core, a fuzzy or partially dissolved core is enclosed in a fluid metallic hydrogen layer rich in helium. The greatest magnetic field in the solar system is that of Jupiter, which is around 20,000 times greater than Earth's magnetic field. Webb telescope photographs now reveal its powerful storms, auroras, and faint rings in crater clarity. According to NASA, the hue of the image shifts from orange and yellow near Jupiter's poles to blues and purples in the middle because many images from the telescope were merged to create an overall composite and display the gas giant on Earth. Even NASA's own specialists were apparently taken aback by the photographs, which also show faint galaxies and thin rings photobombing in the foreground. Jupiter is covered in white streaks and patches and has a vibrant aurora around it. The infrared images were intentionally colored to draw attention to the traits. "We've never seen Jupiter like this. It's all quite incredible," said Imke D. Pater, a planetary astronomer at the University of California who was instrumental in the study. She said, "We hadn't really expected it to be this good, to be honest." Like the video so far? Then make sure to give this video a big thumbs up, as a little action from you can help our channel grow tremendously. Now let's get back to the video. These data are submitted to the Mikulski Archive for Space Telescopes for dissemination after being calibrated by the Space Telescope Science Institute, the SDSCI. As part of their research, scientists then transform the data they have collected into images like these. Citizen scientists or amateur astronomers routinely go through the public data repository to retrieve and process photos in addition to our professionals and SDSCI, who formally prepare online images for publishing. In the visual picture of many Webb photographs used to produce the standalone view of Jupiter, auroras can be seen extending to greater heights over both the northern and southern poles of the planet. The light from the auroras is filtered via a redder color map, highlighting light reflecting from lower clouds and upper hazes. The northern and southern poles may be seen to be surrounded by hazes in a separate filter that is mapped to yellows and greens. The light that is returned from a deeper primary cloud is shown by a third filter that is blue mapped. Jupiter is a gas giant, unlike Earth, and does not have a solid surface. Although it is supposed to have hydrogen and helium as its main constituents, Jupiter has never been large enough to erupt in flames. It too contains several rings, but they are fainter and formed of dust from space rather than ice like Saturn's rings. The fresh pictures provide us with a broad view of Jupiter. The slightly discerning rings are between two small moons that seek to frighten and remedy this. Amorphia, one of Jupiter's 53 named satellites, is the third moon closest to Jupiter and its fifth overall biggest. It completes a full orbit in and is the first to be discovered after the 4 Galilean moons. In these images, the Great Red Spot, a legendary storm that is so large it might engulf Earth, as well as other clouds, seem white because they are reflecting a lot of sunlight. Europa is a moon that is easily seen to the left and likely has an ocean beneath its thick ice surface. NASA's next Europa Clipper mission will aim to reach it. Additionally, the Great Red Spot's shadow may be seen to the left of Europa. Thebe and Metis are the two more Jovian moons that may be seen in these pictures. The Great Red Spot and the equatorial area also have high-altitude hazes, according to Heidi Hamel, Webb transdisciplinary scientist for Solar System Studies and Vice President of Aura Science. The numerous dazzling white spots and streaks are probably extremely high-altitude cloud tops from concentrated convective storms, according to the research. Dark ribbons north of the equatorial zone, in contrast, are cloudless. Unmistakably, a black speck can be seen on the planet's left. This is Europa, one of Jupiter's Galilean moons and a crucial item in the hunt for potentially habitable planets in our solar system. We'll get to this more excitingly later. A separate close-up photograph shows Jupiter's rings with clarity. The Webb telescope has made it possible to clearly detect the distinctive characteristics of Jupiter's rings. The most current photographs also depict the Metis and Theme of Jupiter narrowband images of Jupiter offer breathtaking views of the planet's whole disk. But what came as a real, very nice surprise was the availability of further data and very faint objects. The interior of Jupiter and its upper atmosphere do not mix well. Researchers had believed that convection would mix up Jupiter's atmosphere. If this were the case, the heavier elements would be more uniformly distributed throughout the atmosphere. Hotter gases near the planet's core must ascend to the outer atmosphere before cooling and falling back down. The bulk of the heavy elements that Jupiter has ingested, according to the newly developed internal model of Jupiter, has stayed close to its core and lower atmosphere. The researchers' findings may change how other planets in the solar system were formed, since some region of the gas giant may have a modest convection impact. According to Miguel, Jupiter was the planet that had the most influence on the formation of the solar system since its gravitational pull. Impacted the size and orbits of its cosmic neighbors, and understanding how it formed would have a significant impact on planets that will form in the future. She pointed out that the results also suggest that Saturn may have evolved from a planetesimal. The 3 gas giants in the solar system are Uranus, Neptune, and Saturn. It's important that when we find these new worlds with NASA's James Webb Telescope and in other news, in what seems to be a new era of space exploration, we don't classify them based on their cloudy surfaces. If you agree, let us know what you think about these discoveries in the comments area below. With that being said, it's time for us to say goodbye, but don't be sad as we'll be back with another amazing video soon. And don't forget to hit the subscribe and bell icon buttons so that you don't miss any updates from my channel. See you all soon. Thank you so much for watching.